Okay, I'm going to come around and have some different groups and have some different groups write up their rules. At least you want to go to yours for rule 1. I'll have you put up your guys' rule for rule 2. And I'll have you guys do rule 3. Is it right?
It's not connected.
Oh, I haven't plugged it in because I was giving a test all day. Whoops. It's not you. It's me.
I'm sorry.
Okay, let the light blink for a second. And then do this. Okay.
Oh, my handwriting's really bad.
False. It looks beautiful.
That's really bad.
You guys did an awesome job here. If you want to keep this as extra examples in your notebooks,
Yikes.
if you want to paste it in your notebook or staple it or tape it, you certainly can. If you want to send someone over to grab tapes, we'll talk about some of them and then we'll go through some other examples. But you guys did a really nice job finding the rules. Gorgeous. Looks amazing.
Can't really see.
Awesome. Yeah, these are the 3 rules. Okay. Now, I would double check the rules, if you wrote them down, and make sure that you have, the base B on all of them. Really important is that you notice in the different examples that they keep their bases all the way through. So, in box number 1, problem number 1, it's a log base 3 of 4x being multiplied. So then that's the log base 3 of 4 plus the log base 3 of x. A lot of times I get people on quizzes and tests who's going to drop the base on one of those logs, and you're going to lose points because a log with a different base is a different value. So you have to be careful. You have to remember to keep that log for all of them. I heard people talking about, okay, if they're being multiplied, then it turns into adding 2 logs and then reverse. If they're being divided, then it turns into subtracting 2 logs. So that's an easy way to remember that. Notice if you look at number 4, number 4 on this second box was log of x over 10. And then by your property, that would be the log of x minus the log of 10. Why is the answer log of x minus 1? Log of 10 is 1. It's saying 10, the common log's base, to what exponent is equal to 10? Well, obviously 1. So if you have a log that simplifies, then it will be your responsibility and your work to check for that and simplify it. So you should always stop and think about the logs. Can I do that one in my head? Is that one nice? Is there an exponent for that base that gives me the thing I'm taking the log of? Okay. And then the last one, you just take your exponent and you drop it in front so that it turns into multiplication. Do any of those things sound familiar to you? If you're multiplying, then you add. If you're dividing, then you subtract. If you're raising it to an exponent, then you multiply it. What does that sound like? The properties of exponents. Isn't that true? If you were multiplying 2 powers, x to the 3rd times x to the 5th, then you add their exponents, x to the 8th. If you're dividing those 2 things, x to the 5th divided by x cubed, then you subtract your exponents. And if you're raising a power to another exponent, like x to the 5th cubed, then you multiply your exponents. And remember, what is a log really? An exponent. The answer to a log is an exponent. So the log should follow the same properties. Now, we're going to, on the next slide, talk about how to derive these 3 properties. Okay. And so this information up at the top you'll want to write down in your notebooks. Okay, the yellow box. These things are going to be like our givens. If I say that log base b of m is equal to x, then that implies that b to the x is equal to m. Right, using the definition of a logarithm. So that thing Kaylee asked about on the quiz, it's just being able to place them in the correct spot. And then I need a second log with the same base, so I'm going to change the x and the m. I'm going to use y and n, and I'm going to say y equals log base b of n, some different value. And that would imply that b to the y is equal to n. So there's three properties we're going to run through. You won't have to do all this work every single time. Those properties that you guys found in the Find My Rule, you'll just be able to say, oh, if I multiply two things behind a log, then I add two separate logs, and you'll just be able to use that property. But we're going to show why these things work related to the properties of exponents and what you know about logs. Okay, so property number one is actually called the product property of logs. What does product imply? Multiplication. So we're saying that we have some log base b of m times n. So we have a product behind the log. Okay. Let's make some substitutions. According to my yellow box, what is m equal to? B to the x. And what is n equal to? B to the y. So do you agree, just through like substitution property, I could substitute b to the x for m and b to the y for n? Okay. If I have in there b to the x times b to the y, they have the same base. So what can I do with those exponents? Add them. Okay. So this is really the log base b of b to the x plus y. And then that looks like something from section 6.3. That's one of our inverse properties. If you have a log base b of some exponential expression with base b, what happens to those bases? It cancels out because exponentials and logs are inverses of each other. So this is really just equal to x plus y, which is the sum of the exponents. And remember, the exponents are really just the logs. So if I make another substitution, if I substitute in for x, that's the log base b of m plus y, which is the log base b of n. So I'm just making a substitution at the end to put it back into log form. Okay. So this says that's equal to the log base b of m plus the log base b of n. Isn't that what you guys wrote as your property or your rule? Yes. Can you try property number 2, the quotient? Can you see if you can derive the quotient using these same things? Okay, that you have at the top. So property number 2 is the quotient property of logs, which would be the log base b of m over n. See if you can make the substitutions. It'll be a similar process, but you're going to come up with a different answer. This will get you some practice with kind of making those substitutions on your own. Instead of multiplying b to the x and b to the y, you are dividing them, which means you can combine that to b to the x minus y. subtract your exponents. By inverse property, that's equal to x minus y, and then make your substitutions. We'll say log base b of m minus log base b of n. Now, one important thing to note is that anything that's in the denominator, anything that's being divided, so if it shows up in the denominator, when you break up those logs, this is called expanding, it's going to have a negative in front of it if it's in the denominator. If it shows up in the numerator, it's going to have a positive log. Okay, so you can always know like what sign the log should be if it's in the numerator or if it's in the denominator. Okay, I'll go through property number 3 with you because this one can be a little bit tricky. Okay, but also just interesting to see how all of this works. So this is log base b of m to the n. And on this one, we're really only going to make one substitution. I'm not going to put in b to the x and b to the y. I'm only going to sub in for m. So m is really b to the x. So this is log base b of b to the x raised to the n. I'll leave that second one in terms of n. What do you do with those two exponents? Multiply them. So that's really just log base b of b to the xn, which is xn by properties of logs. And then if you sub in x, x was that log base b of m. Now I'm just going to put the n in front of it, so it's n times log base b of m. That way everybody knows that n is being multiplied by the log, not by the m. Okay? Now again, you will never have to do that as actual work. You'll just accept the properties as they are as you wrote them down in the Find My Rule, and then you can use them in that way. Okay. So hopefully somewhere you have in your notes, and if you don't, maybe add it to your actual notes. Something I know you guys were writing, some people wrote it down when they did the Find My Rule activity. Something like this. 3 properties. So 3 separate properties. Now, you can use the properties either way. So you can use the properties to break things up, and you can use the properties to put things back together. They have different names or different directions. If you take one log and you break it up into multiple logs, that's called expanding an expression. And if you see logs that are being added or subtracted or have the same base or something's being multiplied in front of them, that's called condensing. And so you can go back and forth in the property. You can take it apart, you can put it together, just depends. Does anybody have any questions right now about what is happening? Okay, let's try some examples. Okay, first example. Log base 6 of 3 times x to the 4th. Okay, when I'm thinking about expanding, I'm going to look at the thing that comes behind the log and say, like, do I have multiplication, do I have division, or do I have a power? Well, in this problem, I have multiple things, right? A multiplication and I have a power. Okay. Break up the multiplication or division first, and then do your powers so that it applies to whatever log the thing is actually touching. So this is really 3 times x to the 4th. I can write that as log base 6 of 3 plus log base 6 of x to the 4th And then to fully expand, if I have an exponent, I can drop it in front of the log, right? It turns into multiplication. So this can really be written as log base 6 of 3 plus 4 log base 6 of x. Notice that my log should always have matching bases. And it's expanded. You might look at log base 6 of 3. Can you think of 6 raised to any exponent that equals 3? No. Please don't answer 1/2 because that would be 6 times 1/2, right? Okay. So if you raise it to the 1/2, that would be the square root of 6, and that's not a nice number, so we would call it quits. Okay, let's condense. Log base x minus log base 9. Well, now I see 2 separate logs. Do the logs have the same base?
Yes.
Yes, so I can condense them. Do I see, look on the right side of the property, do you see addition, subtraction, or multiplication in front of a log? You see subtraction, so that condenses back to division. So this will be log of, which one goes on the top? X, because it's positive, and what goes in the bottom? 9. Now, notice this is really like a common error for a lot of people when they first start. A lot of times I get this, log x divided by log 9. Easy mistake to make. But when you think about this, when you condense, you have less logs. You're putting it with 1 log base 10. So this is not the same thing. It should just be log of x over 9. Okay? Okay, I'm going to put some others up and give you a chance to try them. Maybe talk with the people around you.
It's too good to be true.
Yes, of course they'll get a little bit more complicated, right? Pick one. Try to think about, there may be multiple things, so tackle perhaps one thing at a time, or make a plan before you start. Let me know if you have questions as you're working on one, you're really stumped about something. I'm looking at the one thing right now. You can still break this up. So like that one has division, but then in the denominator you also have multiplication. So then you can still expand further. Same thing for you. This one is still being multiplied, so you'll be able to expand again. This one will expand more because 12x is being multiplied. So you can still keep going. Okay, on that first one, I see a lot of log base 3 of 5 minus log base 3 of 12x. Good start. 12x is being multiplied 12 times x. I know sometimes with the coefficient and the variable it's hard to spot that multiplication, but you should also break that up. I see two ways that you can break that up. Some people are saying because they're doing this after this minus sign that they need a group of parentheses, which I would agree. So you could say log base 3 of 5 minus, and then you could do log base 3 of 12 plus log base 3 of x. Does that say it goes together in the denominator? The other thing you can do is remember, if it shows up in the denominator, what sign should the log have in front of it? If it's in the denominator, the log will be a minus. So I could also expand this like the 5 is going to be a positive because it's in the numerator. And then I'm going to have a minus log base 3 of 12 because it's in the denominator. And then I'm going to have a minus log base 3 of x because it's also in the denominator. Which is the same thing, it's just like distributing your negative. Either one is fine with me. Okay, good. If I were doing this condensing over here, log 4 plus 3 log 3 minus log 12, I will put back any multipliers out front, like coefficients to logs. Those are really, used to be exponents. So this is 3 to the third. So that would be the log of 4 plus the log, not log base 4, log of 4. Log 4 plus log 3 to the third is 27 minus log 12. And then now I could condense, that's going to be 4 times 27 because those are both positive, so they go up in the numerator. And then 12 has a negative in front, so it's going to be in the denominator. Let's see, what is that? 9. So the log of 9, which 10 to what exponent is 9? I'm not really sure. I'm going to leave it alone. I'm kind of following this same process. If I look at the one right below it, let's put all the exponents back. The 2 belongs on the x, so that's going to be x squared. This 1/2 belongs on the y, so you could write it as y to the 1/2, but if you raise it to the 1/2, it's also the square root of y. And then this 3 goes on the 4. I'll just write it as 4 to the third, and then this minus sign tells me it goes in the denominator, okay? So if I'm putting that all back together, I'm going to have 1 natural log. My x squared is going to be in the numerator. My square root of y is going to be in the numerator because it has a positive. And then my 4 to the third, which is 64, that's got a minus sign in front of it, so that should be in my denominator. And I'd accept it if you wrote y to the 1/3. That's fine. But then that might help you with this one when you're being asked to expand, right? Okay. So we have the natural log of x plus the natural log of y squared minus the natural log of square root z. Anything in the numerator is going to be a positive log. Anything in the denominator is going to be a negative log. And then, like, some people might wonder about this one with the square root because I didn't give you any properties for radicals, but we know that that's really z to the 1/2. So then we actually can simplify that. So this will be natural log of x. This 2 will come down and be plus 2 natural log y. And then we'll have minus, bring down our 1/2 natural log z. Okay. Anybody got any questions about what we did on those? If I'm expanding, I'll do the powers last. Drop them at the end so you only put them in front of the log that they belong to. Now, if they're like outside a group of parentheses, you might have to drop it early and then it applies to all the logs. Okay. If I'm condensing, I always put the powers back right away because they only go back on the thing that is behind the log that it's in front of. Okay, we've got one more thing to talk about, and it has to do with your calculator. So I'm finally going to teach you how to do logs in your calculator if you don't have that special base feature on your calculator. Okay, and it's called the change of base formula. If you need a calculator, get a calculator. Okay, before I give you the change of base, let's just think about this logically. If I gave you log base 6 of 24, we'd be thinking what in our heads? 6 to what exponent equals 24? And while we don't know, we know what it should be between, right? X is between what two numbers? 1 and 2, okay? 6 to the first is 6. 6 squared is 36. I'm going to say it's probably past 1.5 because 24 is closer to 36 than it is to 6. Okay, so it's like 1 point something, right? We at least know that. Okay, maybe I'll estimate it like, I don't know, 1.6 or 1.7. Okay, here's your change of base formula. Okay. The log base b of u, and b could be anything. We're going to use this. Use when b is not 10 or e, when it's not the common log, when it's not the natural log. Those two things only work in your calculator for log and natural log, base 10, base e. Okay. Basically what you do is you make a conversion. Instead of having base b, which we don't have a button for in our calculator, we're going to do the log of u, so the thing we're taking the log of, divided by the log of the base. And because these logs don't have bases, we're assuming we're using what?
10.
The log base 10. So you have a button on your calculator. Side note, we could also write the change of base as natural log u over natural log b. If we had a button on our calculator that was log base 3, we could do log base 3 of u divided by log base 3 of b. It doesn't matter what the base is as long as you divide both. Okay. So let's try it with log base 6 of 24. Okay. So we're going to find the exact value for log base 6 of 24. Sorry, it's a little bit low there. Okay, so we would do the log of what number on top? 24 or 6? Which one is you? 24 divided by the log of 6. Okay, type that into your calculators. Now, side note, in your calculator, it often brings up a parenthesis after the common log, so you would need to close it before you divide by log 6. Give me 3 numbers after the decimal.
1.774.
774. Is that kind of what we estimated it to be? More than 1.5? Because 24 was closer to 36? So what that's saying is, if we did 6 to the 1.774, it should be really close to the number 24. Now, if you only do 1.774, you've rounded a lot, so it won't be exact. Okay. Okay, so just some other quick examples to kind of reiterate this. Okay. If you were doing log base 4 of 25, you would do log of 25 divided by log of 4. Log base 6 of 8 would be log of 8 divided by log of 6. This will be log of 18 divided by log of 3. If you want to investigate a little in your calculator, that should be the same as the natural log of 18 over the natural log of 3. That's going to give you the same decimal value both times. Okay. Now, if you have a calculator that has that special feature where you could just plug in your base, you are welcome to use that. Although, if there is a question about change of base as a property, you would need to know, like, the log that the thing you're taking the log of goes in the numerator and the log of the base goes in the denominator. You got a homework assignment. It's on the gold sheet. Okay. You can be practicing expanding and condensing and also the calculator work. Now, if you're really getting, I put evens on here, but if you're having a really hard time with the properties, then maybe you start with the odds. Like, do an odd and make sure, check it in the back of the book and make sure you got it. And then try the even. Right? If notes went fast, if you were confused with the properties, do some odd ones before you do the evens.